It may not look like it, but I'm currently training an AI denoise model. So you may be wondering why I'm outside and not inside the data center, but don't worry, everything will make sense in a few minutes. So let me explain. Now, many software offer AI denoise, and these models are trained on large dataset because they must work for everybody. So you, me, and the guys over there. But what if I could train my own AI denoise model? And perhaps it will work better than some other models because it will be trained with my own dataset using my own camera noise profile as well as my own style of photography. And that's why I'm outside. So I'm trying to take a few shots so I can train my own AI denoise model. I've already been taking a few shots inside, but because I mostly do landscape photography, I think it makes sense to train my model using shots from outside. So I will just take a few pictures and then we will go back inside to train the model. So if that sounds good for you, let's go. Now back inside. So what I've done is prepare the same type of pictures as Denoise. If you don't know that model, this is probably what Darktable 5.6 will use if AI is implemented. And it's also what RapidRaw is using since version 1.5.2. So what I've done is I've captured many scenes. And for each scenes, I've captured a few images at ISO 100 as well as a few noisy shots at different ISOs. Now we will use these images to train our model. Basically, we will teach the neural network by telling it, here is a noisy photo, here is a clean one, learn how to transform the first one into the second. And the good thing is that you can train this model with only 8 GB of VRAM. Right now, I have 16 scenes, and let's say I open a folder. As you can see, we have clean images as well as noisy one. If we look at the clean images, they were all shoot at ISO 100, as you can see right now on the side panel. But now, if we look at the noisy shots, so the first one was shoot at ISO 400, and the last one was shoot at ISO 5000. And as you can see, noise everywhere. So now I will run a script that will pre-process all of the raw files. First, it will align all of the images, and then it will stack all the clean images to get something much cleaner. And at the end, we will have many TIFF files from clean to very noisy. Okay, now I will run the script and it will pre-process all of my raw files. Okay, that's it. So I have the final TIFF file. So let me show you. Okay, so right there, I have all my scenes. So let's say I look at scene number 5. So I have my clean image, and then I have different ISOs from 600 to 51,000. Noise everywhere. Now it's time to train our model. So if I run this command, so let me make some small adjustments. Yeah, so now if I run this command, we will train our model. Okay, so what is happening right now is that we are showing the noisy and the clean images to the neural network. And every time it passes the whole dataset, it starts over so the model can improve. So it's a little bit like when you are studying. So the first time you read something, you don't remember much, but the second time you remember a lot more. And every time the model improves, it does a validation. On the 16 scenes I got, 14 are used for training and 2 are used for validation. So what the validation does is that it will denoise the 2 noisy images and compare them with the clean images. Then it will check if there is a big difference between the denoise image and the clean image. And when the model sees that there isn't much differences between the denoise image and the clean image, it will stop the training. Okay, so the training is completed. So it took a few hours, so I'm recording this the next day. So if we look at the last line, we can see the training was 347 epoch. So this is the number of time the model sees the training dataset. And we can see that the best epoch was 247. And the signal to noise ratio for that checkpoint was 37.1. So we get the signal to noise ratio after the validation. So it takes the 2 validation set it denoise them, and then it compares them with the clean images. So if we have a nice signal to noise ratio, it means the checkpoint did a great job removing all of the noise. So the signal to noise ratio is like a numerical value we can use to know if the checkpoint is working fine or not. Now, if I show you, so now these two files were created during training. So the best.pt, that's the best epoch we did. So epoch 247, and it also saved the last checkpoint. So we can try both to see which one works best. So to test if it is working, so maybe it's not removing noise at all. So we will see. So I will use the same picture as last week's video. So I will use this. If we zoom in, you can see noise everywhere. And this picture was not used for training, so the model has never seen this image before. So now I will run this command. So we will use the best checkpoint, and we will use our lizard picture and run it. I think that's it. Okay, so let's have a look. So as you can see, the model is working. So on the left, we have our raw file, so noise everywhere. And on the right, we have our denoise image with the model we just created. As you can see, there isn't any noise left. To be honest, it's a little bit soft. But remember, this is just 16 scenes. So what if I have 50 or maybe 100? I don't know. I will see. So in the next few weeks, I will try to build a database to have more scenes, and I will let you know once everything is done. Also, don't worry, everything will be open source. So when everything is ready and I know it's working well, I will upload it on GitHub so you can train your own AI denoise model. So that's it for me. See you next time.